Welcome to the video on exceptions to the octet rule. We've discussed that hydrogen is a notable exception to our octet rule because it needs only 2 electrons when it bonds, and so we understand that that's because it's the first element and it's right next door to helium, so it just needs 1 electron to be like the nearest noble gas. However, there are some very notable exceptions to the octet rule, and one is elements in group 3A, and this boron is one that is often seen as an exception to the rule. And if you look here around the boron, okay, we have 2, 4, 6 electrons, okay, instead of 8. So it is satisfied with having only 6 electrons around it versus 8. And what it actually has is an empty p orbital around the boron. Oops. It actually has an empty p orbital. And you learn later that this makes boron, or BF3, what we call a good Lewis acid. It has that empty p orbital that electrons can be donated towards. Elements also in the third row have empty d orbitals that can be available to accept electrons. So phosphorus and sulfur can also have more, okay, so they can also be exceptions, but they have more than 8 electrons around them. So if we look here at this phosphorus, we have 10 electrons around it, 2, 4, 6, 8, 10, and this is sulfuric acid here, H2SO4, and it has 12 electrons around it. One thing I do want to make clear is just because phosphorus and sulfur here are defying our octet rule, they don't always do this. So just example here, if you have PBr3 and you drew its Lewis structure, okay, this would fit our octet rule just wonderfully. It would, if you watch the video on the NASB method, it would also fit that. So just because phosphorus and sulfur can have more than 8 electrons around them, that doesn't mean that they always do. Okay, so this here is not an exception, and we could do the same thing with sulfur. All right, thank you for watching.